Hey there, science fans, let's talk statistics. I know it might not sound like the most exciting topic, but stick with me. I know, the word alone might make you want to run for cover. It can seem like a mountain of numbers and formulas, but trust me, it's not as scary as it sounds. In fact, once you get the hang of it, statistics can be quite fascinating and even fun. Statistics are just tools to help us understand the world around us. They give us the power to make sense of data and draw meaningful conclusions. They help us answer questions like, how effective is this new study drug? Or how likely is it to rain tomorrow? Is this new study drug actually effective? These questions are crucial in fields like medicine and environmental science. Does listening to music really improve your focus? Imagine being able to back up your study habits with solid data. The problem is, sometimes those tools can feel a little intimidating, like trying to assemble a spaceship when all you need is a screwdriver. But don't worry, it's all about breaking it down into manageable pieces. But fear not, my friends, we're here to make it simple and approachable. We're going to break down some common statistical tests in a way that even your pet hamster can understand. Yes, you heard that right. We'll use relatable examples, a dash of humor, and absolutely no confusing jargon. You'll be amazed at how quickly you can grasp these concepts. Ready to conquer the world of statistics? Let's do this. Together, we'll turn those intimidating numbers into your new best friends. First up, the Z-test. Imagine you're at a pizza party because, well, who doesn't love pizza? It's a fun gathering, and everyone is excited to create their perfect slice. You notice your friends are putting an average of 3 toppings on their slices. Some go for the classic pepperoni, mushrooms, and olives, while others mix it up with more unique choices. You, being an adventurous soul, go for 5 toppings. You pile on pepperoni, mushrooms, olives, bell peppers, and even some pineapple for that sweet and savory combo. The question is, are you significantly more adventurous than the average pizza eater at this party? Are you the boldest in your topping choices? That's where the Z-test comes in. It's a statistical tool that helps us determine how your topping enthusiasm compares to the average. It helps us compare your topping enthusiasm to the average, considering how much variation there is in topping choices. This means we look at how different everyone's choices are from each other. If everyone's putting 2, 3, or 4 toppings, your 5 might not be that unusual. It could just be a slight deviation from the norm. But if most people stick to 1 or 2 toppings, your 5-topping masterpiece might just make you the reigning pizza champion. You'd stand out as the most daring pizza artist in the room. The Z-test tells us how many standard deviations away from the average your 5 toppings are. This helps us understand just how unique your choice is. A standard deviation is just a fancy way of measuring how spread out the data is. It shows us the range of topping choices among your friends. The bigger the Z-score, the more unusual and impressive your pizza topping prowess. So, next time you're at a pizza party, remember, your topping choices could make you a statistical standout. Next up is the T-test, a fundamental tool in statistics. Let's say you're trying out a new coffee shop in town, eager to see if it lives up to the hype. You order your usual medium roast, anticipating that familiar, comforting flavor, and take a sip. It tastes a little weak, not quite what you expected, but maybe it's just you, or perhaps it's an off day for the barista. This is where the T-test swoops in to save the day, providing clarity in moments of doubt. This test is perfect when you have a smaller sample size and don't know the population's standard deviation, making it ideal for our coffee scenario. In our coffee conundrum, you only have a few sips, your sample, to judge the entire pot of coffee, the population. It's a small bite, but a big decision. The T-test helps us figure out if your weak coffee experience is just a fluke or a sign of a bigger brewing problem. Is it just this cup, or is the whole pot weak? Think of it like this. The T-test is like taking a small sip of coffee to decide if the whole pot needs more grounds. It's a small action with significant implications. It helps us estimate the average strength of the coffee based on your limited but valuable taste test. So next time you sip, remember the power of the T-test. Now let's head over to the college cafeteria for some chi-square action. Imagine there's a heated debate about the most popular food option. Is it pizza, burgers, or salad? Okay, maybe salad isn't winning any popularity contests, but bear with me. The chi-square test comes to the rescue. It helps us analyze categorical data, like food preferences. We can use it to see if there's a significant difference between the observed frequencies, how many people actually choose each option, and the expected frequencies, what we'd expect if everyone chose randomly. So, If way more people choose pizza than expected by chance, the chi-square test will tell us if that difference is statistically significant. Maybe the cafeteria pizza is legendary, or maybe it's just a coincidence. Either way, chi-square helps us separate real trends from random noise. Time for another coffee break. This time we're getting fancy with ANOVA, which stands for Analysis of Variance. Imagine you're conducting a highly scientific experiment, in the name of good coffee of course, to see if different brewing methods affect taste. You brew 3 cups using different techniques: French press, pour over, and good old-fashioned drip. Then you gather a panel of discerning coffee enthusiasts, your friends, to rate the taste of each cup. ANOVA helps us compare the average taste ratings for each brewing method to see if there's a significant difference between them. Think of it like a coffee taste-off. ANOVA helps us determine if one brewing method consistently produces tastier results, or if it's just random variation between cups and coffee tasters. So far we've explored some powerful statistical tools. But just like you wouldn't use a hammer to saw wood, you wouldn't use a t-test when you need a chi-square. Choosing the right test depends on the type of data you have and the questions you're trying to answer. Using the wrong test is like trying to fit a square peg in a round hole. It just doesn't work. It can lead to inaccurate results and misleading conclusions. Imagine telling your professor that a new study method is effective based on a flawed statistical analysis. Yikes! Speaking of consequences, using the wrong statistical test can have real-world implications. In academic research, it can mean the difference between a groundbreaking discovery and a retracted paper. In business, it can lead to poor decision-making and lost profits. But it's not all doom and gloom. When used correctly, statistical tests are incredibly powerful tools. They help us make sense of data, draw meaningful conclusions, and make informed decisions in all areas of life. So whether you're analyzing survey results for your sociology class or conducting experiments in a research lab, mastering these tests is essential for success. Congratulations, my statistical superheroes. You've made it through this crash course on common statistical tests. Remember, practice makes perfect. The more you use these tests, the more comfortable and confident you'll become. Don't be afraid to ask for help from your professors, TAs, or even your statistically inclined friends. And remember, statistics aren't just about numbers and formulas, they're about understanding the world around us and making better decisions. Now go forth and conquer the world of data. Large sample, known population variance. Small sample, unknown population variance. Analyzing categorical data and relationships between variables. Comparing means of 3 or more groups.